Hi, my name is Mayur. In this series of videos, we are discussing about MGD Outliers package and its OutlierNinja class. If you have watched last video of this playlist, then you are already familiar with installing and importing the package and the class. This video might be the longest one of the series. Today's video is about fit method. In this video, I will be covering how to create and train the object of the class, and then next we will be talking about fit method. We will see what exactly happens in the background when we apply this method. Maintaining the flow, we will also quickly see a couple of class attributes, which are limit factors and numeric columns, and at the end we will also check out the two methods from this class. So let's begin. Alright, I have already prepared a Jupyter notebook in which I have imported basic libraries and a sample car crash dataset from Seaborn. I have selected this dataset because it contains numerical columns and few outliers which are easy to detect and visualize. Then I have also created a box plot for each numeric column, which confirm that there are few outliers in alcohol and not distracted column. Next, I have also imported OutlierNinja class from MGD Outliers package. This we have already discussed in the last video. Next, we will see how to create an object of this class and then fit it on the dataset. It's very easy. We will create an object with name Outliers. We just create an instance. And while creating an object, you will see a parameter limit factor, which is set to 1.5. It is an IQR threshold which helps to determine upper and lower limits for detecting the outliers. I will show it later in the video where it is used. Now I will run the same. The object is created, but it is not yet ready to provide us the answers. First we have to call fit method on it. So outliers.fit, and then we also have to provide the data set, which is data, and that's it. The object is now created and trained with our data set. Now once the object is trained, we can access the limit factor that is used to determine the outliers. We can do this using limit factor attribute, for which you have to type outliers dot limit factor, and you can see the limit factor, which is 1.5. Similarly, you can also check the numerical columns that are identified and processed by our OutlierNinja class. This can be accessed using outliers dot numeric columns, and here you will see the numerical columns from the data that are identified by our OutlierNinja class. Without doing any of the calculations, we can also get IQR values for all the numeric columns. For this, you have to call getIQR method on the object. So outliers dot getIQR, and it will return the series containing column names and their respective IQR values. Similarly, we can get the lower limits and upper limits for each column by calling getLimits method. So outliers dot getLimits. This code will return a dictionary containing column names as keys and list of upper and lower limits as values, and it looks like this. So you can see column names as keys, and in this list first value is lower limit and the second value is upper limit. And that's how we can access the attributes and call the methods on the object. Now in the next part, I want to show you the internal calculations performed by our OutlierNinja. So we will calculate IQR and limit values manually and compare the results with the ones provided by our OutlierNinja class. So let's see. I have already written a block of code at the bottom. we'll use the same code, and we will also use alcohol column as an example and calculate interquartile range and limit values for this column. So the column name is alcohol and the limit factor is 1.5. Now to find the interquartile range, we first have to find the lower quartile and the upper quartile. So Q1 is the lower quartile and Q3 is the upper quartile. And when we run this, we get these values. And interquartile range is nothing but the difference between upper quartile and the lower quartile. So when I run this code, I will get the interquartile range for alcohol column. So interquartile range is 1.7099, and if you see here, we got the same answer. Of course, it is rounded off. So this is how the interquartile range is calculated. Now this IQR value and the limit factor, or the IQR threshold as people say, determine the lower limit and the upper limit for the column. So the lower limit is nothing but the lower quartile minus limit factor times the IQR, which is given by this code. And the upper limit is the upper quartile plus limit factor times the IQR, which is this code. And now when we check the lower limit, it is 1.32, which is same as the value here, and the upper limit is 8.1689, which is also same as this value. And that's how these values are calculated using OutlierNinja class. In the next videos, we will explore more methods which makes your life easier while finding those annoying outliers. So stay tuned and thanks for watching.